This is the third video of my hard thermo questions in my series. And first, give this question a go before I give you the explanation. Okay, so this is a PV graph and two different ideal gas changes are shown. I, which is an isovolumetric change because pressure changes, but volume remains constant. And II is, I don't know what the hell that is. We don't need to know that. So this question asks us, in which case is the thermal energy supplied larger? So let's first recall the second law of thermodynamics, which states that heat transfer is change in internal energy plus work done. Okay, so what I'm going to do is I'm going to find heat transfer of I and II individually, and then I'm going to compare them. So let's first go with I, which is the red curve. Q is change in internal energy plus work done. We don't know Q for now, but we know that work done is 0. Why? Because there's no area under the graph. For all isovolumetric changes, work done is going to be 0. But for isobaric changes, where the graph looks like this, because pressure remains the same but volume changes, there is work done because there is an area under the graph. Anyways, so Q will be equal to internal energy. Now, internal energy is equal to, change in internal energy is equal to we don't have to know this right now. We just have to know that for I, heat transfer is equal to this change in internal energy. I'll explain why we don't need to find out the change in internal energy now a bit later. Let's then work out the heat transfer for II. Now, the reason why I said we don't need to exactly know what this value is because change in internal energy for I and change in internal energy for II is going to be the same. Now, this is because we start off at the same spot and we end up at the same spot. So no matter what kind of path you take, even if I had an ideal gas change that went like this, we start at A, end up at B. So the internal energy changes for all of these three curves are the same. Now, we can tell that for II, change in internal, for I, we can tell that heat transfer is change in internal energy plus work done, right? So to figure out whether the thermal energy supplied higher, oh my god, I can't talk. So to find out whether the thermal energy supplied is higher in AI or II is by finding out what is work done, or more specifically, if work done is bigger than 0 or work done is smaller than 0. Now, we can do this by knowing that work done is PV, or area under graph. Now, because this is some kind of weird semicircle, it is very confusing to look at. So I'm gonna, quote unquote, split the curve into two parts. From here, A to C, and then C to B. I just draw the arrows. Okay, let's look at from A to C. The work done would, the work done for A to C would be this colored part. No, because you can tell that there's an gas expansion because the arrow is pointing that way. You can see that this is work done by the gas. So for A to C, work done is positive. Now, let's look at from C to B. For C to B, we can tell that the area under the graph is this much bigger chunk. So we can tell that the magnitude of the work done for C to B is higher than magnitude of work done for A to C. Then let's work out the sign of this work done. Is it positive or is it negative? Answer is that it's negative because the air is going that way, meaning that there is a contraction, meaning that work is done to the gas. So work done is negative. But then remember that the magnitude of C to B is higher. So if we add work done for A to C plus work done C to B, we have a negative number. So internal energy plus work done, which is the heat transfer that II experiences, is smaller than just the change in internal energy, which that's the same as the heat transfer of I, because this work done is negative. Hence, answer is